And we are recording.
Both good, bad, worst, best, all the work out there. So.
Thank you.
Yeah.
Alright guys,
As
so
means I don't want to only show you the best work, means there is some bad work too. So.
because you're supposed to give us 3 copies. Student A, student B, student C. So your exemplar students who got like 100, and then your ones that get like 70-ish. And then your ones that get like 50-ish.
That's you.
Kind of think like that.
Okay.
Like they really got it, oh they got it, they're kind of missing something, oh they don't have it at all. So that's what we try to find out, what's the gap between this group and this group, this group and this group. Okay? So that's good. So we'll go ahead and get started. So thank you guys for submitting your student work. Today we're going to analyze Algebra 2. So we're going to analyze Algebra 2. First I want us to look at the standard. So you have a copy of the instructional focus guide. If you look at your handouts, okay. So we got a copy of the instructional focus guide. So in ELA, they have rubrics. When they write stuff like that, they have rubrics to go by. Well, in math, we don't really have a math rubric. So what the state has done, they've come up with an instructional focus guide, which you guys have copies of and have seen. But now going forward, we're going to use this as our rubric to help identify whether or not kids are meeting the standard or not. It gives us those check fors, those look fors to see how kids are doing. So the standard we're doing is A2FIFA1. So real quickly, look at the standard and let's determine what students are supposed to know and be able to do. Take about 1 minute. There's like 15 seconds. Alright, so what are students supposed to know and be able to do?
Most of the things that they're supposed to be able to know are what things like intercept, max and mins are, and behavior, things of that nature. And in order to show it, they have to be able to identify them all the way up through level 3 is mostly identifying. And once we're done identifying, looking at graphs, identifying them in the functions, level 4 it gets up to the actual graphing of it, not just a rough sketch.
Just how in behavior works, what it means, what in behavior actually means. Like how do you read it? Does positive or negative play a part, in that, or
Okay. Mr. Shaw, you underline some things.
Oh yeah. So what I see is for the level 2 students, like not only from the graph, if they are given a table of values, then they should be able to identify which of these values are the intercepts or which of these values are maximums or minimums. So not only from the graph but also from the table. That's for the level 2, and for the level 3 students, they should discuss about the features of the graph, identify the features of the graph from the table, and then interpret the meaning of that key features. The meaning of those features. Just for example, when they say maximum, what does that mean? Or minimum, what does that mean? Or intercept, how can you show what is intercept?
So to add to what you're saying, Mr. Shaw, because I underline that as well, like they need to know it in relation or in context to like a word problem. Because if you read the scope and clarification, it says real world context.
Yeah.
So 9 times out of 10, that's a word problem, like a balloon going in the air or a ball going in the air, something like that. So meaning in context of a real world problem.
And what I find interesting is between level 2 and 3, the main difference between level 2 and 3 is like they break out the different types of functions that we want to determine. Like it seems like they go over the level 2 concepts, but then they break it into square root, they break it into cube root, they break it into polynomials, and they have a paragraph for each one of those. Versus in problem 2, they're just talking about identifying the key features of the graph, not saying what kind of function it is.
And what I noticed that you brought that up was that, so there are clear, level 3 is where we want them to be. Okay, everybody's clear on that. Level 3 is where we want them to be a master. Level 2 mentioned quadratic. Did you read the standard? Do they ever mention quadratic in the standard?
They don't actually mention a specific, other than scope and sequence. Scope and sequence is the only spot where they mention
The types,
the types.
right?
They don't really
Because-
mention it in the standard at all.
Because the types, and a lot of times we don't look at the scope and sequence. Scope and sequence tell you the type of graphs we should focus on in algebra 2. Quadratics is a level 2 because it's an algebra 1 standard. You get what I'm saying?
Yep.
So if we're doing algebra and quadratics in our classroom, then we're not mastering that standard. We gotta move them past it.
Right.
Okay. So I just wanna make sure we're clear, everybody can see this distinction between on level versus not on level. Okay, great. So we're looking for, when we get ready to analyze the student work, we're looking at, did they interpret the intercepts correctly, identify the intercepts correctly? Did they give the max and min? Did they identify the end behavior? Did they look at positive and negative? Okay, everybody's okay with that? So these are the things they're supposed to know, and they show it by either looking at a graph or a table. And then basically this is identified. So this is really like a DOK 1 and 2. This is not even like DOK 3 and 4, which is high level blooms. Can they just identify and then interpret what it means? All right, so moving on our agenda, we set the norms, we looked at our key exemplar. Let's look at the student work. So how does this compare to the exemplar? So if we look at your student work, we're looking at student work A. Student work sample A. So Ms. Duncan, can you share a little bit about this assignment?
Well, it was a student-driven lesson. I previously went over like the practice worksheet with them on Tuesday. And so I handed those back and I had them to use that worksheet to help with this worksheet. So, excuse me. Basically what they needed to do was to deal with the inequalities, how to find the zeros for the x value, write them in set notation, and sketch a graph for those. That was the basic overall. How to find solution sets as well. So that was the basic gist of this particular worksheet today.
Okay, so two things we're gonna focus on. Let's focus on finding the zeros and sketching the graph.
Okay.
So if we go and look at question number 1, would that be the first question?
Fluency.
Finding the zeros.
Yep.
Question number 1. So in this exemplar, did the student correctly identify how to find those zeros? Because that's part of the standard when we interpret the graph.
It looks like he's just plugging the value.
Yeah, based on the work, yeah. All they're doing is plugging in the value.
You plug in the value and then he's showing that, okay, this number is greater than 0, so and then he or see whatever that student is, choose that number.
So this is
And I don't know, like, if that student start from exactly from this choice, or he tried like from all these 3 and then got the 4th one, but he wrote only the 4th one here, and he did for these 3 somewhere else. It's not clear that.
Oh, well, okay, cause I have their scratch paper as well.
Okay.
Yes, for this, what to find the answer for number one, they were to plug in these different solutions, and they know that if, once they get down to their final answer, if the solution is true, then that would have been your answer. If it was not true, skip it and move on to the next value. So the student only wrote down this one because 1, 2, 3, and 4 were not true statements that they knew, you know, and they were limited.
But like Mr. Shaw said,
Okay.
he pretty much said, alright, they're pretty much plugging them in, right? So,
Mhm.
are we really identifying zeros here? It doesn't.
Not for number
Doesn't seem like
one.
we're identifying zeros because we're looking at inequalities, not.
Right,
Now,
not
whether the
numbers.
inequalities is valid or not.
Yeah,
That's what
right.
we are looking
Yeah.
for here. From the student work, that's what it's.
And the zeros will help us find that based
Right.
on the, number line that we set up.
But the thing is, our objective, according to this one, should be like finding the zeros and then interpret that, what's that
Exactly.
meaning over there. And then based on that information, you choose a choice.
So I'm not sure that this particular question itself
Yeah,
is something that
probably more
fits the
of
standard.
these would probably fit into that category.
Yeah, there
So
we
we're
go.
looking at the assignment, I didn't copy
The backside.
yeah,
It's okay.
because we just looked at the front, part. So how does the back, now that you brought it up, how does the back?
The back actually coincides with what we're examining
So the
today.
back, we're finding the zeros in
Yeah.
order to set up our number line, so they're honing down into that.
Right.
Whether or not they actually realize what that, the thing that I would love to see in this assignment was the actual graph of the parabola, so they could actually see what that
What
looks
that
like.
looks like.
So they could see that it's actually greater than, and why it's in between the two values, and why it's either in between or outside of the two values that you find for zeros.
Mhm.
I think that would really be cool for this assignment. It would actually help them understand it more.
Oh, okay, this is student C. I was like, why is this student?
Yeah, it was like student A, student C, so they looked
Okay,
at,
okay.
took the identities out. Okay, so looking at this, so now we just got one, that's fine, I'm done. Right, so what would you say would be the gap between this student and, you got the other student C? This would be student,
This is student A.
that's student A.
This is student B. And this is student C.
Okay, well,
Student C, we can tell that
student C,
Right.
we don't know whether or not that's a knowledge problem, or if that's a work ethic problem, whether or not they just didn't do it.
Right.
So, let's toss that one out.
Okay.
And student A, I think is, I see a lot of work, I see, some good interpretation of what the number line is supposed to look like. I see good factoring. I question, there's a little bit of factoring issues going on, I can tell, because when we look at the leading coefficient, like on letter A on number 7, the leading coefficient didn't work into the factor, so something happened there. So again, looking at the graph may have helped them, because if they would have plugged that into their calculator, they would have seen that that zero didn't match. Something that they can do in real quick, like, and plug that parabola into the calculator and see if it works. Let's see, but I mean, a lot of the technique is there, it's just they didn't follow through
Just
on the
simple
technique.
stuff,
I
right?
said they did like this.
Yeah,
all
they-
these things.
they-
They are showing
They,
what.
they
so-
missed that middle step of
Right.
splitting it up and factoring by grouping.
Right.
so what's that misconception?
They missed that, they're supposed to split up, then they find out the values that add to BB.
Right.
They split up the,
They
that to
didn't
the
show
X
the
values
whole
and
work.
factor by
I'll
grouping.
say that one. Student's thinking is not coming everything over here, but he's thinking and he got that over there.
Yeah.
But it's not on paper.
He's using the
That is
concept of A
thinking
equals
is-
1 versus the A being something greater than 1.
Right,
That's
and
the
this
big thing.
particular student does show
Yeah,
that
this
part.
this student shows that part, but then, for some reason, I don't know if they didn't have time to finish, but again, we're seeing some really good work here
Mhm.
on student B, but they just didn't
Yeah,
get
but no.
finish.
Right.
So I'm not sure if I'm not checking answers, obviously, but, they got to a certain point, and I didn't draw a number line here for some reason, and the misconception here was the equal to part, they circled their equal to part versus their inequality part, but that, according to the standard, we're more looking for the 0 anyway, so.
Okay, so what I've heard is, in order for the students to master this standard, they had to show some sort of steps, use some sort of strategy.
Yeah.
And then a misconception came in that while they were using the strategy, they were confused on whether they were factoring when A was greater than 1 or when A is equal to 1.
Right.
Okay? And
What
then,
happens when that happens?
okay, A is greater than 1, A, so what's happening here? You're saying if I looked at the graph, it would be able to give me a different.
It would show me,
meaning.
yeah, you look at that meaning and realize maybe that would say, oh my gosh, my answer is incorrect, what did I do? And have the student actually maybe persevere and go back and say, oh, where's my mistake?
Okay. And then for student B, we need to figure out what happened that stopped them from getting to the number line part. So
Right.
is it something up here that they don't maybe understand? Because look how they wrote the inequalities.
Right.
So there's an inconsistency right here how they're writing their inequalities. What you got?
I have seen this, someone is teaching this in this school system somewhere because all of my pre-cal students wrote the inequality backwards.
Yeah, they're writing it backwards.
And all of my pre-cal students have write the inequality backwards.
Cause I don't think they understand like how this is actually read. I think from when I look at it,
What they did is true, but it's outside the standard norm. So right
Right.
now, they're writing 6 is greater than or equal to X, which is greater than or equal to -1.
right,
Normally, we put the lesser value
to
on
the
the left
left,
side as we read it.
right,
That's
So-
legally not wrong, but that's not the norm. to
Right,
do.
it's not the norm to do.
Right,
It's not
right,
wrong,
right,
it's
right.
just not what you
Not the
normally
norm,
see.
not
And you-
the
right,
And you will
what
not see
we
this
accept
convention
as
on a test.
mathematical things all over the world.
right.
You won't
Yeah.
see this type of convention on a test. It would be the other way around every single time.
Yeah.
Yeah.
They won't write it like that on a test. Mathematicians don't accept it.
So the misconceptions that we take from here, and I'm trying to pick 2 because we talked about it a lot.
Okay.
The ones that we can work on immediately
Mhm.
is notation, being
Yeah,
mathematically precise
Uh-huh.
and how we write our number sentences.
Knowing how to read it so you
Okay.
can know how to
So
write
let's
it.
all write that down. The first thing
Precise and
is
accurate.
writing. So how can we fix that? Is that like a whole class reteach, or can we get in?
I think it will come, we need to work on it as we go through other inequalities. So we're gonna have lots of opportunities to do inequalities. It's something we can hit and highlight as we do other inequalities. I don't think it's gotta be a specific reteach time at this point in time. I think we're gonna have other opportunities to do inequalities.
Yeah, I'll add on that one. What we can do is, like, whenever we get at inequalities, as a teacher, we'll focus on it. We'll intentionally write that way and then say what the students are thinking on that one. And then it will take another 1 or 2 minutes extra time on that lesson, but that will help the students to focus on it.
Right.
Means you don't have to go back and then reteach, okay, today's lesson objective is to figure out notation, you know.
Right.
But whatever lesson is, we can fit into that one
Exactly.
because you will use that almost in almost all chapters.
And that's exactly what I did in pre-calc. We went over the test and we talked about, that particular thing. We actually brought up when we were talking about how they did on the exam. I said, I don't know where you guys came up with this concept, but let's talk about it. We need to do it this way.
Yeah.
Okay, what about the difference between a greater than 1 and 8? Because that's the second misconception.
That one is included in A.
That's gonna have to be a corrective instruction. We're gonna have to look at that as an individual basis,
Yeah.
I think, and kind of pull them out when we're doing factoring of polynomials maybe. And that way we can add the quadratics into it as like a tier 3 exercise or a corrective instruction time for those people. So we get into polynomials starting next week or the week after that, we can actually make that into one of the tier 3 activities, and pull out those corrective instruction folks to do that one.
So our reteach strategy then is to do a small group during tier instruction. So we're gonna address that misconception. The set notation, what I was thinking, you guys made a great point, it's gonna come back up later, but right now, I probably can put this same problem up as bill work. Maybe, or what I would do is, I know I like to blow stuff up. I would scan this and maybe blow it up or put it, I scan it and include in my PowerPoint and do a error analysis.
Okay, where did the mistake?
Help the students determine where the error happened.
Okay.
So error analysis is probably what I would do. Or a student may say, hey, I wrote it a different way. Then you can have that discussion, that conversation in class. What's the difference? And then Mr. Shaw's point, does it even really matter?
Right.
No, it doesn't matter, but to help us better understand, that's kind of what I would do.
Right.
Okay, and so, let's see, what do I want to do? our agenda says we discuss our strategies and activities. So we just discussed strategies and activities. We're gonna go back over this and do a error analysis, doing bell work. Error analysis, doing bell work. For this student here who mastered it, when you make those groups, your tier 3. So for your tier 1 group, I will pull in what Mr. Stroder said earlier, the graphic. Because you need to push this student to get to that next level to see what's going on.
Right.
So while you're reviewing with the other group on the A's,
Let
the
them
code
play
flip,
around with it in the
let them
calculator.
take it higher to the calculator. That way they're looking at the calculator. I'm not really writing anything. I'm just playing with figures on the calculator, trying to make what I'm working
Makes
out
sense of
make
everything.
sense on the calculator.
Right.
Then that ties back to the standard because the standard says I need to know how to look at it on the calculator and I need to know how to graph it on paper also.
Right.
So you're tying it back in both ways. Okay? Any questions with that? We clear?
Do we want to say, you mentioned that we wanted to decide when we wanna do this. I know my
Yes.
personal opinion would be to put it in with the same lesson, that bell work that you're talking about, the same lesson when I start factoring polynomials is when I would like to do it.
Okay.
Well, I don't have a specific date for that yet, but, that's when I would like to do it. I think we'll be doing that. I will be doing it next week. So,
Well, the week after next.
no, I'll be doing it next week.
Oh,
'Cause
okay,
they want-
never mind,
okay.
never mind.
My kids will be doing it next
Never
week.
mind.
I may not be.
I
but
got you,
my
never
kids will
mind,
be.
I got you, I got you, I forgot you,
So you okay to do it
I
next
got
week
you.
too?
Yeah, mine's
Okay. So we'll
Well,
do it.
You're probably the week after that.
Yeah, I probably
Okay,
be the
next week
week
is
after.
for Schroeder. We'll say Duncan is the next week. I was gonna say something.
And then another thing that I like to do, like the little smalls, like the little small pieces, I like to hit those hard during my March Madness blitz. That's when I like to hit the
That'll be
small.
definitely
Yeah,
happening
that's,
because you have a much smaller group of students, so it
Right.
can be more individualized.
so yeah, that's when I like to reiterate and hit the small stuff, like, you know, real hard,
It's
real
coming.
quick.
And then when we get the IXL, you'll be able to hit it even
Yeah.
harder. It's coming.
Okay,
Just
you'll
hold on.
explain to me later, I
Well,
don't like being in the
my
dark, you
blitz.
guys understand that,
And
right?
then another thing about this
Is it an
standard,
I-40?
yeah,
Trust me, you won't be.
it's gonna be
How far
fine.
is it on I-40?
What's I-40, what?
You said it's coming, so I believe it's coming on through I-40 or
Oh.
maybe I-55.
That's it.
Yeah,
That's
It's
good,
on that
that's good.
240 loop right
That's
now.
good.
Yeah.
That's
Still going around.
good.
Still going
That's
around.
good. So,
So
that's
this standard does come back up,
Yeah.
because as you know, because you gotta teach it in different types,
Yeah.
polynomial, exponential, so we're not really worried about it, it does come back up. But when it comes back up, now we know how to address the misconception on the
Right.
front end, so that when we teach it again, we'll kinda have it there, okay? My last thing, and then I think we're done, when we do our student work, I want you guys to start doing, feedback. Okay, so we're gonna take the idea from ELA, cause I think it's great, and it's called praise, question, and suggest.
Okay.
So something the student did great,
Mhm.
let's praise them on it.
Okay.
So thank you for showing all the steps to solving this problem or something like that. And I gave you guys the handout that goes with it. So when we praise them, we provide specific positive constructive feedback, something that the writer did well, okay? Or something that the writer did well, okay? And that just kind of lets students know, oftentimes we don't tell them what they're doing right.
Right.
So, this time we can tell them, what they're doing right.
And I
it's
named
just-
it differently. For me, I call it glows and grows.
Okay,
Yeah.
and that's the same thing.
Yeah.
Same
And
thing.
then some sentence stems that kind of help you. Again, it's kind of ELA, so just change, paragraph to the problem. All right, question. Ask them, I was wondering, what were you thinking when you started working the graph, but you didn't complete the graph?
Right.
What was your thinking there? Because you kind of want to engage in a conversation with the student
Right.
and get them thinking about what it is that, okay, what was I doing? Oh, I really didn't mean to put that 80, I meant to put this 8. So now you kind of get them to self-correct. And then a suggestion, maybe next time,
Try blah blah blah.
yeah, try it this way. Or, try working this out in pencil and not pen. I mean, that's pretty there. But again, sentence stems are here to kind of help guide your thinking. So we have these sticky notes, which are the big ones with the lines on it. So I didn't like to write on students' papers. I will write my suggestions on like a sticky note and then stick it on the paper. Or it's also effective if you're doing like your small group instruction and you see students doing something, you can kind of write them a note, slide it on their desk, and then you can keep it. Write them a question. have them think about it, come back, hey, did you get a chance to answer my question I just asked? And it just kind of help them do it. So when we submit our student work on Mondays, okay, thank you. Include your sticky note. So include a copy of the sticky note.
Okay, now when you say include a copy of the sticky note, a sticky note to where I just show you what I asked the student or the conversation between me and the student, does the student reply back to me or
That's
they
your
just
PQS.
implement
Yeah,
it?
that's your
Okay.
PQS. Because hopefully they would reply back to you. But we
On
wouldn't have it
paper
time.
or not a response?
Not a response.
Okay, got it.
It'll be with you. Okay, questions?
Yes,
I like that.
I think that is practically not possible for me in the sense because maybe I misunderstood the word. So if I don't note on that one and then I take a copy of this one, it won't be hard for me to like relate which feedback goes to which one or what.
It's based on student, so I don't.
Because I like to write on the same place where the
If you,
student.
if you decide
But
not,
that's a preference.
if you don't wanna use a sticky note,
Yeah.
you don't have to, nobody's
have
forcing you to do a sticky note.
Yeah, you
For
can write on
example,
the
let me
paper.
see like, okay, how did you get this?
But if you ask me that question, how did you get this? I won't know what you're talking about. So more specifically, you can say,
Okay, that may not be the right feedback, but see,
Right.
means I'm writing like not enough work, again, but I wrote some word like in one or two students like.
and so
Just to
when you
reflect
write your questions, I want you to think about how is this question going to help the student think about my thinking?
Okay.
Because if you write a question, not enough work, well, maybe I didn't know the work to even put on the paper.
Right. Okay.
Maybe that's all the work that I can do. So when you say not enough, I'm not sure as a
Okay.
student what you would be talking about.
Okay.
But writing it on the paper
Let
is
me
fine.
see, did I took that picture or not? Whether I was like very much specific. I believe that was very much specific. I want to show that, but I don't think I took that picture. Okay. Sorry about that, but maybe next time I'll try to take that. But when I write on that one, and then when we come over here discussing, see just for example, I put a question mark over here, what after this, because this student didn't complete the word. How did this student know about this? It's not clear over here because they didn't write the geometric statement or theorem or possible, whatever they used it, or is it from the given statement? So it's not clear on that word. So that's how I like to put it. Because just for example here you see, now how did you get this? No reason over here. Now here he wrote a reason over here, that's fine, but this is equal to what? It's not clear over here. What is this? So I like to put this kind of notation.
So my reason for wanting to push this with all ELA and math is because the feedback that we're giving students is not helping them to better understand their misconception or where they're making up.
No, when
Because
I'm
if
ready
you
to
gave
put
me
it-
my paper with a question mark, you might as well put an X on and tell me it was wrong because they're both in the
No,
same
no, it's not like, okay, you are thinking this way, I'm grading this in your absence, and then I put it, I return to you, now you don't know, that makes sense to me. But I'm putting this in front of you, okay, you did this, and then I'm asking you, how did you get this? Why is this over here, why it shouldn't be here? I'm talking to you as well as grading in front of you. So that's what I'm trying to do. And I say my students, I will not grade your work in your absence. I will grade your work in your presence, we'll have mutual conversation. Yeah, that takes time, but it's mutual conversation. It's live. Because a lot of things going on in my head. I say
Unless they come to my house, I'm not gonna be able to do that.
Oh,
Right,
yeah.
it's like, yeah, I'm
I
trying.
got you, but anyway, my
That's
thing
what
on
I'm
this,
doing now,
Mr.
so.
Mr. Shaw, I think right now what we're thinking, what we're talking about, you're giving positive feedback. I think what she's asking for is more annotation of what you're saying, not just the
Okay.
question mark, stuff like that. She's not
Mhm.
saying that you're doing anything wrong.
Mhm.
What she's
Right.
saying is that
Yeah.
we need that annotation. If you're doing this
No, I'll
feedback
put it.
back and forth, that's what she's looking for
Okay.
is that feedback, not and.
No, I'll make it more clear.
Yeah.
It's not clear
And-
now, I
and-
see that, okay.
Mr. Shaw,
Like,
Mr. Shaw.
I'm listening to you.
You got it? You ready? Okay. Okay. All right. Retest. Stop. You good? Okay.
Alright, any questions about that? No? But just think about, I mean, but seriously, think about, you got your system. Everybody has their